Hello everyone, welcome to the second video about Lesson 2.5, Transformations of Functions. In the first video, I reviewed the types of transformations that you might see on functions, and then I showed you some basic transformations with a quadratic function. Now, do you have to use quadratic functions on these? No. Sometimes you'll be asked to use square root functions, sometimes you'll ask to use cubic functions, but all of those transformations work in the same way. So if you haven't watched that video, you should definitely go back and watch it. But in this video, we're going to look at functions that, well, aren't familiar to us yet. So let's take a look at one of those examples. In example 5, we're told that the graph of y equals f of x is shown. They want us to sketch the graph of each function. And notice what they've done is they've told us that y equals f of 2x for part A. Now, notice what this is. We're multiplying the variable by 2. So that one, think about this, it's a horizontal stretch or compression. Now, when you do a horizontal stretch or compression, you're multiplying by the reciprocal of that factor. So this particular transformation is a horizontal compression by 1/2. So what we're going to do is we're going to take the x values from each major point in this graph. So that's all of the bottom values, all of the top values. We're going to multiply those x values by 1/2. So if this was at 1, now it's going to be here at 1/2. If this was at 2, now it's going to move to here to 1. And that's going to look like this graph here. So this pink graph, what I've done is I've compressed it horizontally by 1/2. Notice this furthest out point used to be at 4. Half of 4 is 2. So this pink graph is the one that shows you that horizontal compression by 1/2. Now looking at part B, it says y equals f of 0.5x, or f of 1/2 x. So again, notice this is happening to the variable. It's being multiplied by a number. So that's another horizontal stretch or compression. And you're multiplying by the reciprocal of that factor. The reciprocal of 2 is 1/2. So this is a horizontal stretch by 2. So what we're going to do on our graph is we're going to take the x values and actually multiply them by 2. So this was at 1. So 1 times 2 is 2. It's going to move over to 2. This was at 2. 2 times 2 is 4. It's going to move over to 4. So I'm stretching it horizontally by 2. And it would look like this graph here. So the blue graph, notice this was at 1, now it's at 2. So I've stretched it horizontally. I've taken each point and moved it over by twice the amount it was. So this was at 2, now it's at 4. This was at 3, now it's at 6. So it's twice as far from the y-axis that it was. Let's take a look at another example. In this one, we're using a familiar graph, but there are lots of transformations happening. So they say to sketch the graph of the function f of x equals 1 minus 2 times x minus 3 squared. So that is a quadratic. So I have the quadratic parent function right here. Here's the x-axis and the y-axis. Now, the first thing that we're going to do is we're going to identify the transformations that were done. So pause the video, see if you can find all of the transformations. There's a lot going on here. I see, I think, 4 transformations. So pause the video, see if you can find them all, and then press play to see if you're right. Okay, this one is basically added to the outside of the function. So it's a vertical thing, and it is a translation because we're adding or subtracting, and it's gone up by 1. So vertical translation up 1. This minus sign here, that's times the 2, that's a reflection. It's a reflection across the x-axis because it's happening, again, outside where your x squared is. This 2, that is times, in parentheses, the x squared, well, that's a vertical stretch by 2 because you're multiplying the x squared by 2. It's not happening inside the parentheses. It's happening outside, making it vertical. Now, finally, this minus 3 that's inside the parentheses with our x, That's a horizontal change. And again, they're adding or subtracting, so that's a translation, and it's gone right by 3. So that's how all of them work. So what we're going to do, and I'm going to use the 0, 0 point as an example. I'm moving it right, 1, 2, 3. I can't stretch yet, but I can reflect across the x-axis. That means I'm going to have a downward parabola. It's going up 1, and the stretch would take the point that used to be 1 down and 1 over from this, and I'm going to multiply its y value by 2, and it's going to end up right here. So let me bring up that graph so you can see what happened. So notice it is over 3, it's up 1, it's reflected downward, and the point that should have been here is now down here. Okay, so that's how that works. Now let's look at another related topic to this. We're looking at even and odd functions next. Okay, an even function is a function that when we evaluate for a negative value, it's going to equal the same thing as if we evaluated for the positive form of that value. So notice if I put in -1 to the x squared function, which is what this graph is, I would get +1. If I put in +1, I still get +1. All of the negative values over here have equal results as their positive counterparts on this side, which means that it is symmetric over this y-axis, meaning anything over here is reflected straight across to this side. An odd function is one where when I evaluate for a negative value, it's the same thing as multiplying the entire function by -1, meaning every single sign for every single term is going to change to what it wasn't. So if it was positive, it's changing to negative. If it's negative, it's changing to positive. Now, this is symmetric around the origin, meaning this first quadrant is rotated 180 degrees into the third quadrant. So it's kind of flipped upside down here into the third quadrant. So that is an odd function, and you can recognize it from its graph because things that are over here are reflected all the way down to here. They're rotated. Okay, so let's take a look at some examples of equations that we need to determine if they're even or odd. In this example, they just said determine whether the functions are even, odd, or neither. So in part A, they give us this function. So what we're going to do is we're going to evaluate for a negative value. So I'm going to put -x into this. And when you do, a negative to a 5th power is a negative. So this is going to have a negative sign. And x to the 1st power, when you put a negative in there, it's going to change this sign as well. So this is what it would look like. Notice that all of the signs changed. This sign changed and this sign changed. So that makes it an odd function. So pause the video, try B and C, and then press play to check your answers. In part B, when I evaluate for negative, the sign on this one would not change at all because notice there's no variable attached, so it just stays as it is. And a negative value to a 4th power would not change this sign at all, so it stays the same. Notice none of my signs changed, so it's even. In part C, when I put the negative in, this is going to turn negative because 2 times -x is -2x. But if I square the negative, it wouldn't have an effect on this particular sign. So only one of the signs changed. So that doesn't work for either type, so this is neither. So that's it for this lesson. Make sure you bring any questions you have to me.